Alright guys, for the lesson today, Thursday, October 12th, there are 3 skills that we need in order to be successful. So I'm going to post 3 instructional videos on how to do those 3 skills. The first skill is simplifying radicals. Okay, so say we had an example like this. So number 1, we've got the square root of 80. This is a radical. This symbol is a radical, the square root of 80. Now, what this means is what number times itself is 80? Well, I don't know. I know that 8 times 8 is 64, 9 times 9 is 81, so the square root of 80 should be somewhere between 8 and 9. And if we put this into our calculator, we would see that it's approximately 8.9. Now, in math, we have a way of simplifying radicals. And what we want to ask is, does 80 have any perfect square factors? Does 80 have any perfect square factors? Okay, what do I mean by a perfect square factor? So perfect square. So our perfect squares are numbers like 1, 4, 9, 16, and hopefully you're seeing this pattern. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and so on. These are our perfect squares. So I want to ask, does 80 have any perfect square factors other than 1? Because of course every number is divisible by 1. So let's think of numbers other than 1. And I look here and I see, yeah, 80 is divisible by 4, but we want to pick the largest perfect square factor. And 80 is also divisible by 16. So what I'm going to do is I'm going to write this as the square root of 16 times the square root of 5. 16 times 5 is 80. So I can split up a radical into 2 different radicals. The square root of 16 times the square root of 5 is the same thing as the square root of 80. And now I know what the square root of 16 is. That's 4. So this simplifies to 4 square root of 5. So once again, we want to ask, can I simplify this radical by asking, does it have any perfect square factors? Let's do another one. All right, number 2, got the square root of 27. Now the square root of 27, I don't know what that is off the top of my head. I know that 5 squared is 25, 6 squared is 36. So 27, the square root of 27 must be somewhere between 5 and 6. But let's simplify this by asking, does 27 have any perfect square factors? Well, let's see, 27, yeah, it's divisible by 9. So I can write this as the square root of 9 times the square root of 3, because 9 times 3 is 27. And the square root of 9 is 3. So the square root of 27 simplifies to 3 root 3. Let's do another one. Let's do the square root of 35. Okay, the square root of 35, I know that's got to be pretty close to 6 because the square root of 36 is 6. So this is going to be like 5 point something. So let's see if we can simplify it. Does 35 have any perfect square factors? Well, it's not divisible by 4, it's not divisible by 9, not 16, not 20, no. Square root of 35 cannot be simplified because 35 has no perfect square factors. So we cannot simplify this. It's simplified as far as it can go. Alright, let's look at one more here. And then we'll look at a problem that's a little bit different. Okay, so how about the square root of 98? Okay, the square root of 98. Well, let's check. I think it's probably divisible by 4. So you can always use your calculator and pull out your calculator and you can say, okay, 98 divided by 4. No, that's 24.5. You know what, I'll show a calculator here. So like 98 divided by 4. No, can't do that. Let's try 9. How about 98 divided by 16? No chance. Not 25. Maybe 36? No. Let's try 49, then we'll quit. Oh! Hey, 98 is divisible by 49. Once again, 98 divided by 49 is 2. So what does that tell me? That means I can write this as the square root of 49 times the square root of 2. And 49 is a perfect square, so that's 7 root 2. There we go. Okay, so once again to recap, to simplify a radical, we want to split that radical into two radicals, the product of two radicals, where one of them is a perfect square. A perfect square. Okay, let's look at one more similar type of problem that we need to be able to simplify. So what about the square root of 6 times the square root of 21? Okay. Well, 6 does not have any perfect square factors, nor does 21. So I'm just going to multiply these together, because it's telling me to multiply times. So this is the square root of 6 times 21. Well, 6 times 21 is 126. But this might be able to be simplified. 126 might have a perfect square factor. So maybe 4. No. Maybe 9. Oh yeah, there we go. 126 is divisible by 9. So I can write this as the square root of 9 times the square root of 14. 9 times 14 is 126. So this is 3 root 14. Let's do a couple more of those. How about the square root of 10 times the square root of 15? I can't simplify the square root of 10 because 10 is not divisible by 4 or 9. Nor can I simplify the square root of 15. It doesn't have any perfect square factors. So I'll just multiply. But 150 might be able to be simplified. And I know that 150 is divisible by 25. 150 divided by 25 is 6. So I can write this as the square root of 25 times the square root of 6. And we know that the square root of 25, well, that's a perfect square, so that's 5. So this simplifies to 5 root 6. Let's do one more. Square root of 8 times the square root of 28. Okay, there's a couple ways I could do this, because I look and say, hey, the square root of 8 I can simplify, because 8 is divisible by 4. And same with 28. 28 is divisible by 4. So I'm going to go ahead and simplify by writing the square root of 8 as the square root of 4 times the square root of 2. And I'll write the square root of 28 as the square root of 4 times the square root of 7. Well, the square root of 4 is 2, so I have 2 root 2 times 2 root 7. Well, this is just multiplication. 2 times the square root of 2 times the square root of 7. So I can multiply these in any order because of the commutative property of multiplication. So I'll do 2 times 2 is 4. And square root of 2 times square root of 7 is square root of 14. So this simplifies to 4 root 14. Alright, so that's how we simplify radicals. I hope that was helpful.